Hey, welcome everyone to the fourth episode of MicroPython series where I'll make sure that you all get comfortable on using MicroPython on ESP32 board for any of your project. This episode is all about Wi-Fi, starting with the very basic Wi-Fi scan example code in MicroPython. After that, we'll be learning about how to use this Wi-Fi in access point mode. After that, we'll be learning how to use it in the station mode to get connected to the nearby Wi-Fi router to get the internet access. After getting the internet access, we'll be requesting the websites and APIs using the get request method. And in the end, we'll be making a very interesting project of controlling home appliances connected to the Blink IoT platform by requesting the APIs from our ESP32 board running MicroPython. Now, this is one of those episodes which you all were waiting for because this is kind of a step ahead in IoT using MicroPython. So without wasting time, let's get started with this video. This video is sponsored by Altium, which is a PCB designer based software company. Now, if I tell you one very interesting feature of this software, then here in Altium Designer, you can design rigid flex PCB. Now, what is that? So till now, you must have designed the PCB which is like rigid, like solid PCBs that we are not able to bend. But here in Altium, you can design a PCB in which some of the parts are rigid, solid, and some of the parts are flexible, which can bend, and the PCB can, we can bend it in a two-fold manner, just like the modern day smartphone, right? So this is a really very interesting, useful, and unique feature of the software. Well, you can also try out this and many other unique and interesting features of this designer software by just clicking on the link mentioned in the description. Yes, by clicking on the link, you'll get access to the free trial version of this software. So go ahead, try out the free trial version of Altium Designer software. Now, before starting this episode, I'd like to tell you that if you're watching this video for the very first time, I'll suggest you to watch out the previous episode of the series because every episode is a continuation of its previous episode. So do watch out the other episode of the series. The link is in the description. Okay, so let's start with this episode. So I'll open the Thorny on my system, and here let's start with the first example code, which is to scan nearby Wi-Fi networks. And for that, we'll be importing one module called as network. Now, this is again the module which comes along with the MicroPython. Now, there is one question like how to check if the particular module is available inside your MicroPython version or not. For that, you just need to type here in the REPL as help into the circular braces modules, close the inverted comma, close the circular braces, and press enter. And here are all the modules that comes along with your MicroPython version. And here, as you can see, the network module is available, so we can easily use it. Okay. So after importing the network module, you just need to type these lines of code. Let me explain you one by one. So here, first of all, we have declared the Wi-Fi object which is responsible for all the Wi-Fi related activities. And here we have configured our ESP board first to go inside the station mode. Now, why station mode? It's just because to scan the nearby Wi-Fi networks, we need to have the board to go inside the station mode. Okay. So here STA stands for station. Okay. After that, we have to type this Wi-Fi.active into the bracket true to turn on the wireless, driver inside the ESP32 board. After doing that, we can do all the Wi-Fi related stuff. So first of all, we are just scanning the Wi-Fi networks, and for that the command is Wi-Fi.scan, and we are saving all the scanned data inside the variable called as networks. And in the end, we are just printing the network. So by uploading this code, we should get the nearby Wi-Fi networks printed here inside the terminal. Okay, let's try and test this code. So I'll click on the run button. I'll save this code inside the MicroPython device with the name main.py. Okay, I'll click on the OK button, and yeah, as you can see, here we are getting the Wi-Fi networks, like the nearby Wi-Fi networks scanned by our ESP32 board, and it also contains the SMS05, which is the router inside our Techie SMS Studio. Okay, so this is a simple code to scan the nearby Wi-Fi networks. Now let us move ahead and let's try to configure it in the access point mode. And for that, you just need to change here from station to AP, that stands for access point. Okay, so I'll remove all this thing because we no longer need this Wi-Fi scan as of now, because we won't be able to scan Wi-Fi by using the access point mode. Okay, so now in the access point mode, we need to provide the SID name and password to our ESP board that will be displayed in all other Wi-Fi enabled devices. And for that, you have to type one command as Wi-Fi.config into the bracket. You need to type ESSID, and here you need to provide the SID name of your ESP32 board. So I'll give the name of this board as Techie SMS. Okay, that will be great. And after that, here we need to provide the password. Okay, so password will be let's just keep it very simple: 1 2 3 4 5 6 7 8 Okay, and here you need to type one more command, which is this. So this will enable the, what you can say, or rather this will tell the system that we are using it in a secured manner. Okay, so here you need to provide the authentication mode as well. Okay, so with this we have successfully configured our ESP32 board to access an access point, and we have created the SSID name and password. Okay, now to see the IP address, we just need to type the command as print and into the bracket wifi.if config. Okay, so this will print the local IP address of this particular board. Okay, so that's pretty much it about this access point mode. Let's just click on the stop button first, and now let's click on the play button or the run button. Okay, as you can see, it already printed the what you can say IP address of our ESP32 board. And if I go inside my laptop and scan see the Wi-Fi networks, as you can see, the Techie SMS appeared here with this lock symbol, which reveals that this is a secured network. So if I click on this, it should ask me for the password. Let's click on the join button, and here I need to enter the password. So I'll type it as 1 2 3 4 5 6 7 8, and if I click on the join button, my laptop should get connected to this particular board. Okay, as you can see, it got connected to the Techie SMS Wi-Fi or the access point. Okay, so this is how you can use the ESP board into the access point mode and provide the Wi-Fi SSID name and password. Now, if you don't want to provide the password and keep it open, you just need to type this much line of code and it will be an open network. Okay, so that was it about the access point mode. Now let's just move to the next step, and let's try to connect our ESP32 board to the Wi-Fi router, and let's get the internet access from that particular router. Okay, so for that you first need to change this into the station mode once again. Okay, and after that here you need to type one command as wifi.connect. Okay, and inside the bracket you need to type the SSID name and password of the nearby Wi-Fi router which you want to get connected with. Okay, so I'll type the SSID name and password of my Wi-Fi router in the studio. Great. Okay, so with this command it should get connected with my what you can say Wi-Fi router. And to check whether it is connected or not, we have one command here inside this MicroPython, which is wifi.isConnected. Okay, so this function will return true if our board is connected with the Wi-Fi. So let's just give an if condition here. So if it get connected, let's just print the local IP address assigned to this particular board. Okay, let's just try to upload this code and let's see what we are getting in the results. I'll click on the run button, and as you can see, we didn't get anything inside this particular terminal. It's just because this command was no doubt executed, but it like takes some time to get connected with the router. And just after this command, the MicroPython jumped onto this line, and like it just saw that it is not at all connected yet, and hence this condition was not satisfied and jump out of this. Okay, so here what we need to do, we need to provide some kind of delay to give this command some time to get connected with the router. Okay, so for that what I'll do is, first of all, I'll type on condition as while not of wifi.isConnected. Okay, and here I'll just write pass. Okay, that will do nothing. Okay, so until unless the Wi-Fi is not at all connected, it will be staying inside this while loop only. And as soon as it get connected, this condition will not be satisfied. It will jump onto this while loop, go inside the if loop, and if it is connected, which it hopefully should, it will just print the local IP address. Let's just try to run this code. Okay, now as you can see, it got connected, and it also already printed the local IP address assigned to this particular board. So this code is perfectly working. Now here is one mistake still. Now if I provide some wrong SSID name and password, you can imagine the code will be stuck here for infinite. Like this will be an infinite loop, and our code won't be able to jump out of this while. So we need to provide some kind of timeout period, so that if in case the router is not at all available, in case you have provided wrong credentials, it will jump out of that while loop after a particular time interval. Okay, so for that I already written one code, and that code is this. Okay, so this is that code. Let's just try to understand this code line by line. So network module is imported, time module is imported, and a timeout variable is declared with the initial value 0. Okay, pretty simple. We have configured it in the station mode. After that, we are first of all, deactivating that Wi-Fi, and after 500 milliseconds, we are activating it again just to restart the Wi-Fi. That's a normal thing. After that, we have written this command to get connected with the nearby Wi-Fi router, and as you can see here, I have provided the wrong name. Okay, so my real router name is SMS_Geo5, but I just removed this underscore to see what happens when we provide the wrong credentials. Okay, so here what I did is, first of all, I provided if condition that if not of Wi-Fi is connected, that means if it is not at all connected, so initially this condition will get satisfied. It'll just go inside this print, inside this if condition, and print as connecting inside the terminal. After that, I have provided while loop with two conditions: while not of Wi-Fi is connected and timeout is less than 5. Okay, so if both the conditions are true, then only it will go inside this while loop. Okay, so initially both the condition will get satisfied, okay, because it takes some time for Wi-Fi to get connected. Okay, so it will go inside this while loop and will just print 5 minus timeout. That means it will be printing in the reverse order, like 5, 4, 3, 2, 1. Okay, so we are printing the timeout print in reverse order. We are incrementing the timeout after interval of 1 second. Okay, so what it will do is, so now our code will jump out of this while loop if the Wi-Fi gets connected or timeout is greater than 5. Okay, so in both that condition, that while loop will be not satisfied, it will jump out of that while loop. Okay, so in case the Wi-Fi is connected, it will jump out, and here this condition will be satisfied and it will just print as connected. And in case it is not at all connected, then this condition will become false. Again, the code will come out of this while loop and it will just print as timeout. Okay, so right now we have provided the wrong credentials, and now let's just try to click on the run button and let's see what happens. So click on the run button. As you can see, it started running. It says connecting, then 5, 4, 3, 2, 1, and timeout. Okay, so as I provided the wrong Wi-Fi credentials, it didn't get connected. It waited for 5 seconds and it jumped out of the while loop and it says timeout. Okay, so we are not at all stuck inside any infinite loop. And in case if I provide the right Wi-Fi credential, click on the run button. As you can see, it says connecting 5, 4, and connected. Okay, so it took 2 seconds to get connected with the router. Okay, so yeah, that was a pretty simple yet useful code to get our board connected with the nearby Wi-Fi router without getting stuck inside the infinite while loop. Okay, so yeah, that was the thing. Now let's just move on to the next step and let's just use some internet connectivity to do some real life task. Okay, let's try to request one website using the ESP32 board, and for that you need to write these line of code. Okay, let's just try to understand this code line by line. So first of all, network module and time modules are pretty simple, which are already included, and here one new module is included, which is uRequest. Now to check whether the uRequest is available or not, you just need to type here as help. Inside the circular braces, you just have to type modules, and if I press enter, as you can see, the uRequest is somewhere here. Okay, uRequest is already available, so I can use it. Okay, so this is kind of a smaller version of the request module available inside the Python. After that, these line of code will just print the nearby Wi-Fi network, which is optional. I'll remove it just to make it less confusing. Okay, after that, we are connecting to the Wi-Fi router. Pretty simple. Again, this while loop and if condition just to make sure it doesn't get stuck inside the infinite while loop. As soon as it gets connected, we'll just print connected, and here we are using the uRequest module, which is uRequest.get. Now after writing this command, we'll be able to request any of the API, any of the website and stuff like that. Okay, so I have just requested the example.com. Let's just try to request this particular example.com from our browser and let's see what we are getting. Okay, so here I'll request it, and it just print as example domain and this all line of code. Okay, this is all we are getting inside the example.com. Let's try to request using the ESP32 and let's see what we are getting. So with this, you will be able to request it, and we'll be storing inside this request variable, and we can see its status code and the response in text format by writing these two commands. Okay, so with this, we'll be able to see inside the terminal, and in case it is not at all connected with the Wi-Fi, it will just print as timeout and not connected, which is pretty simple, which we have seen inside the previous code. Okay, so let's just try to run this code and let's see what we are getting. It says connected, and okay, so we got the text response. So first of all, it says connected, which is printed here. After that, it printed 200, which is nothing but the status code. The successful communication status code is 200. Okay, and after that, it just printed the text format of the web page that we have requested. Okay, as you can see, it says example domain, which is written inside the web page here, and after that, this tag, which is this domain is for use illustrative purpose, which is written somewhere here. Okay, so we got the response from this website, and this is how we can use the get request method to request the actual website, or we can also use it to request some APIs to do some real life tasks. Maybe some API to get the current temperature, current weather status, current date and time. Any API you can use here. Okay, but we'll be using it for some interesting purpose, and we are landing on to the last code of this particular particular video, which is to request the Blink APIs to control the home appliances which is connected to the Blink cloud already. Okay, so for that the code is this. Okay, so this is the code which will be help us to request the API and to control the appliances. Let's just try to study this code one by one. Okay, so first of all, here we have included all these three libraries, which is pretty simple. After that, we also include this pin from the machine model. It's just because what we are doing is we are using the boot button of the ESP32 board, and as soon as I press the boot button, it will request one API and the particular light will be turned on and off. Okay, that's why we have included the machine module as well. Okay, after that, some of the variables are declared, pretty simple, and here we have defined as pin 0 as input because the boot button is connected to the digital pin 0 of the ESP32 board. Okay, and now what I did here is I have created a connect Wi-Fi function, that is a user defined function which is responsible to make all the Wi-Fi related connectivity task. Okay, that is like taking the credentials and connecting to it, also waiting for the timeout period. In case it is connected, we'll print connected, if not, just as not connected. Okay, so this is the user defined function, and here I have to provide the proper SID name and password. This is a wrong SID name. I'll remove it and write the correct name. Okay, perfect. Okay, so this is one of the user defined function. Second is the button IRQ, the button interrupt request. It's just because I have also provided this button as an interrupt. Okay, so it's a falling interrupt, and as soon as this interrupt occur, it will call the function as button underscore IRQ. Now this interrupt is already discussed in one of the previous episodes, so you should definitely watch it out if you are not at all understanding this. Okay, so basically as soon as I press the button, it will be calling this function, and inside this function what we are doing is we are just toggling the status of button status. So if it's at 1, it will be toggled to 0. If it is 0, it will toggle to 1. So that's what we are doing here. Okay, so after that, inside the while loop, that means inside the infinite loop, what we are doing is we are checking if the button status is true, we are requesting one API link, and in case the button status is false, we are requesting some other API link. Now what is this API link and how it will work? Let me tell you. So this API link is provided by Blink IoT company only. I will copy this link and I will paste them here inside the main browser. Okay, let's try to understand this API. So first of all, what we have to do is we need to provide the authentication token of our Blink project here. After that, we need to provide on which pin number we want to send the data, and here we need to provide which data to be sent. So by using this particular API, I will be able to send the data I'll be able to send the data 1 on the virtual pin V1, and let me show you this in action as well. So as you can see, here is my Blink project on the smartphone. So right now, as you can see, the button 1 is already on, and if I turn it to 0, as you can see, the button 1 turned to off. Okay, if I change it to 1, it turned on. Okay, and if I change the value to number to V2, I'll be able to control the second button. So if I turn it to 0 and press enter, as you can see, the button 2 changed to 0, and if I turn it to 1, as you can see, the button 2 changed to 1. So using this API, we'll be able to send the data directly to the Blink cloud, and we'll also be able to control the actual hardware appliance which is connected to the same Blink project. So in this particular video, I'm using one of my previously made project in which I was able to control the home appliances using the actual Blink IoT platform. Okay, and now I will try to control that same appliances with the help of this API links. Okay, so here what I did is I just provided the value 1 whenever the button status is true, and I have provided the value 0 whenever the button status is false. After that, what I did is I'm just checking the status code, whether it is successful or not. So if it is 200, that means it's a successful request. I'm just printing as request successful, and here it should be light on. And here also I check the status. If the request successful, it will just print as request successful and light off. And after doing those requests, we need to type this command as req.close to close that particular, what you can say, request. Okay, so that's the compulsory command to enter. Otherwise, you won't be able to request the next API link. Okay, so yeah, that was the simple line of code. Okay, I hope you got to understood all these things, because those are very simple stuffs. Okay, we are just connecting to the Wi-Fi. Okay, we are just using the button as an interrupt. We are just requesting a link based on the button status, which is changing with the help of the interrupt. Okay, let's just try to run this script here, and it says connecting, and it is connected. Okay, so as you can see, the smartphone screen is available shown in the video, and if I press the boot button, as you can see, it says request successful, light off, and as you can see, the button also turned off. And if I press the boot button once again, it says request successful, light on, and the button 1 turned on. Okay, so it is successfully working here inside the Blink IoT platform. And when I turn on the actual hardware project, as you can see, I'm able to control this tube light by pressing the boot button. Like when I press it once, it turns on, and when I press it again, it turns off. Okay, so that's the actual IoT project that we successfully made using MicroPython running on an ESP32 board. Do click that like button if you are loving this series, if you're enjoying this series, if you're learning something new with every episode. Okay, so yeah, that was the basic Wi-Fi thing. Still, we are remaining a lot with Wi-Fi, like using web server, local web server, okay, so everything, web sockets and stuff like that, okay. So we'll be learning this kind of thing in upcoming episodes, so make sure you subscribe to the channel if you don't want to miss out on any of the episode. Also share this video with your friend who you think should start learning about MicroPython from very basics to some advanced level. And that being said, I'm just ending this video here, and now just wait for my next video to explore, learn, share with me, Techie SMS.